So today, I'm going to explain the metric system, known more formally as the International System of Units, which is abbreviated as SI. Now, some of you might think that's a little strange that it's abbreviated SI, considering it's the International System of Units. You might think it should be IS. Well, it's abbreviated SI because the International System of Units was developed in France, and there it's called System International, hence SI. Alright, now the metric system measures 7 different things. But before I get into those, I'm going to explain the prefixes. So to do that, we're going to start with a base unit. And going up from this, we have deca, hecto, and kilo. And going down, we have deci, centi, and milli. Now, each of these prefixes goes by a power of 10. So if our base unit is 1, then deca is 10. So if, for example, we have 1 decameter, that means we have 10 meters. And continuing this process, we have 100 for hecto, and kilo is 1,000. Now, going down, deci is 1/10, or 0.1. Centi is 1/100th, and milli is 1,000th. Now, 3 of these prefixes, milli, centi, and kilo, as well as, of course, the base unit, are especially common and are used a lot. The other 3 prefixes, deci, deca, and hecto, are used, but not nearly as much. Now, there are prefixes that go beyond these, and for going up, they are mega, giga, and tera. For going down, they are micro, nano, and pico, or pico. Now, whereas these prefixes went by a power of 10, these prefixes go by a power of 1,000. So, mega is 10 to the 6th, because kilo is essentially 10 to the 3rd, so this is now 10 to the 6th. Giga is 10 to the 9th, and tera is 10 to the 12th. And for going down, we have micro, which is 10 to the negative 6th, and keep in mind this is 10 to the negative 3. Nano is 10 to the negative 9, and pico is 10 to the negative 12. Now, these expanded prefixes aren't used very often either. And there are even more prefixes that go even farther, but those are used even less. Alright, now, for the metric units themselves, I'm going to start with an easy one, which is the second, abbreviated S. Now, the second is the metric method for measuring time. And it can use the prefixes, for example, nanosecond. However, the second does have its own methods for increasing time measurement, which are more often used. Now, what I mean by this is there is the minute, which is 60 seconds. There is also then the hour, which is 60 minutes. By the way, minutes is abbreviated MIN, and hour is abbreviated HR. But an hour is 60 minutes, as well as 3,600 seconds. Now, you've of course heard of this. In fact, as far as I know, time is only measured in seconds and its constituents. So, you should be familiar with this. Now, the next measurement thing that I'm going to talk about that the metric system measures is length. And length is measured in meters, abbreviated M. Now, meters is the metric system replacement for feet and yards. Now, to convert feet to meters, what you do is you take your measurement in feet and multiply it by about 0.3. And that will give you the approximate length in meters. Now, to give you an idea about how long a meter is about the height from the floor to the top of your computer monitor that you're now watching this video on. Assuming, of course, that your computer monitor is at about eye level. Now, meters use the standard metric system prefixes, unlike seconds that had their own special method. And one of these standard metric system prefixes that meters use is the centimeter, which is abbreviated cm. C for centi and m for meter. Now, the centimeter is the metric system replacement for the inch. And the conversion factor for inches to centimeters is about 2.54. So multiply your length in inches by 2.54, and that will give you the approximate length in centimeters. Now, a centimeter is about the width of your fingernail, so you have an idea about how long a centimeter is. Now, another metric system length measurement is the kilometer, which is abbreviated km. K for kilo and m for meter. Now, the kilometer is the metric system replacement for the mile. And to convert miles to kilometers, you take your length measurement in miles and multiply it by about 1.6, and that will give you your approximate length in kilometers. Now, I don't have any fancy method to use to give you a general idea of about how long a kilometer is, but you would generally use kilometers when measuring your distance you traveled in a car. Now, the last measurement system for length that I'm going to mention here is the millimeter, which is abbreviated mm. M for milli and the other m for meter. Now, the millimeter does not actually replace any commonly used imperial unit, because there is no real imperial unit about the size of a millimeter. But, to give you an idea of about how long a millimeter is, it is about the height of your fingernail. So it's rather short. Now, related to length is volume. And the metric system measures volume in liters, which are abbreviated L. Now, liters is the metric system replacement for gallons. And to convert gallons to liters, you multiply your volume in gallons by about 3.8. Now, volume is also commonly measured in milliliters, abbreviated ml. Now, milliliters are equivalent to a centimeter cubed, which is more commonly known as a cc. So if you've ever heard that term, now you know what it means. But a milliliter, at least in civilian use, is commonly used with baking, such as teaspoons and tablespoons. So the conversion factor for milliliters to teaspoons is by multiplying your volume in teaspoons by about 5. And that will give you your approximate volume in milliliters. Now, the third thing that I'm going to talk about that the metric system measures is mass. And mass is measured in kilograms, abbreviated kg. Now, notice that it is kilograms and not grams, which are abbreviated g. Now, this is because kilograms are closer to the mass of things that we would actually want to measure. Now, the reason that we call it kilograms, and that the creators didn't just have a slightly more massive gram, is because when the metric system was being created, things were a lot lighter, and the people that made it figured we'd be measuring the mass of things that were more around the mass of grams. And they didn't really think we need kilograms as much. However, with the development of heavier things, like cars, kilograms have become a lot more needed, and actually heavier things than kilograms have started to develop a need. As such, kilograms has become the standard unit for mass. Now, the kilogram is the metric replacement for the imperial pound. And to convert pounds to kilograms, you take your weight in pounds and multiply it by 0.45. Now, grams are the metric system replacement for ounces. And to convert ounces to grams, you take your weight in ounces and multiply it by about 28 to get your approximate mass in grams. Now, notice that pounds and ounces measure weight, while kilograms and grams measure mass. Now, mass is constant. Wherever you go in the universe, mass will stay the same. Pounds and ounces, however, are dependent upon the gravitational acceleration of the system you happen to be on, in our case, Earth. So, while on Earth, there is a constant conversion factor, or at least relatively constant, between pounds and ounces, if you were to go into space, the conversion factor would be different. Alright, now the next thing that I'm going to talk about that the metric system measures is temperature. And temperature is measured in degrees Celsius, which is abbreviated with the little degree symbol and a C for Celsius. Now, degrees Celsius is the metric system replacement for the imperial degrees Fahrenheit. Now, there's actually a specific conversion formula to get from Fahrenheit to Celsius. And that is, if we have Celsius, and then we take our Fahrenheit minus 32, and multiply that quantity by 9/5, we get Celsius. So, if you take your Fahrenheit temperature and go through the process, you'll get the Celsius temperature. Now, because that can be kind of annoying to just do repeatedly, I'm going to give you a few common Celsius measurements. 0 degrees Celsius is the freezing point of water. 100 degrees Celsius is the boiling point of water. 37 degrees Celsius is the average human body temperature. And about 23 degrees Celsius is comfortable room temperature. Now, Celsius is not actually the official measurement for temperature in the metric system. The official measurement is Kelvin, which is abbreviated K. Now, notice that it is Kelvin and not degrees Kelvin. Kelvin is not measured in degrees. Now, the conversion factor between Celsius and Kelvin is rather simple. If you want to get the Kelvin, you simply take your Celsius measurement, add 273 degrees, and that gets you your Kelvin measurement. Now, the reason it is this way is because minus 273 degrees Celsius is absolute zero, the coldest it can get. As such, 0 Kelvin is absolute zero. That means that there are no negative numbers in Kelvin. Now, the next 3 measurements I'm going to talk about are not used in common everyday life. You're really only going to use these if you're going to actually do science. However, since they are official measurements of the metric system, I'm going to mention these anyways. Now, the first of these is the mole, which is abbreviated MOL. Now, the mole is essentially a measurement of how much stuff you have. It measures that there are 6.02 times 10 to the 23rd particles per mole. So you'll have this many molecules or atoms or elements in 1 mole. Now, moles are often used in conjunction with grams, not kilograms, to figure out molar mass, which are then used with chemical equations. Now, the 6th thing that the metric system measures is electrical current. And electrical current is measured in amperes, often called amps and abbreviated with an I. Now, amperes measure how much electrical charge passes through a specific point in a current in 1 second. Now, the 7th and final base thing that the metric system measures is luminous intensity. And it measures luminous intensity with candelas, which are abbreviated CD. Now, a candela is approximately the amount of light one candle gives off. And it essentially just measures how lit up an area is. So, that was my video about the metric system. So now, hopefully, those of you unfamiliar with the metric system now have a better understanding of it and will be better able to use it. But I hope you enjoyed it, hope you learned something, and see ya!